The exploration of space, from the past to the future. Space exploration is one of humanity's greatest challenges and ambitions. From ancient times to the present day, man has tried to understand the universe, discover new worlds, and expand the boundaries of his knowledge. The development of astronomy, engineering, and technology allowed the transformation of theoretical quests into real missions, paving the way for a new era of exploration. Space exploration is not only a matter of scientific curiosity, but also of strategic importance to mankind. With the potential to exploit space resources, search for habitable exoplanets, and develop technologies for interstellar travel, space exploration has the potential to change the course of human history. Historical review, from first observations to space missions. Early civilizations such as the Babylonians, Egyptians, and Greeks had a deep knowledge of the movement of the heavenly bodies. Galileo's development of telescopes in the 17th century revolutionized astronomy, while Newton's theory of gravity laid the foundation for understanding the motion of the planets. During the 20th century, technological advances enabled the first manned and unmanned space missions. In 1957, the Soviet Union launched Sputnik 1, the first artificial satellite, marking the beginning of the space age. Then, in 1961, Yuri Gagarin became the first man to fly into space, achieving orbit around the Earth. This event sparked an intense space race between the superpowers, the United States and the Soviet Union, which eventually led to the landing of man on the moon in 1969 with the Apollo 11 mission. Since then, space technology has evolved rapidly. Unmanned missions such as Viking and Voyager have enabled exploration of Mars, Jupiter, Saturn, and beyond the solar system. The technologies developed during these missions are still used today to further our understanding of the universe. The space race, Cold War, and technological developments. The 1960s were marked by competition between the United States and the Soviet Union, known as the space race. Yuri Gagarin's mission in 1961 made the Soviet cosmonaut the first man in space, while in 1969 the United States responded with the successful landing of the Apollo 11 mission on the moon. The space race was not limited to manned missions, but also included the development of satellites, space stations, and robotic missions. In 1971, the Soviet Union launched the first space station, Salyut 1, followed by NASA's creation of Skylab. In 1986, the Soviet Union launched the Mir space station, a precursor to the International Space Station, ISS, which was launched in 2000. Future space technologies. The development of new technologies is essential for further space exploration. Some of the major innovations include nuclear drives, could greatly reduce travel time to other planets. Inflatable space stations reduce the cost of construction and transportation into space. Solar sail ships can be used for interstellar travel exploiting the pressure of solar radiation. The role of private initiative. Companies like SpaceX, Blue Origin, and Virgin Galactic are leading the commercial space exploration revolution. Private space programs are lowering the cost of missions and bringing new innovations such as reusable rockets. Detection of extraterrestrial life. The search for extraterrestrial life is one of the main goals of space exploration. Methods are used, such as radio telescopes, SETI, to detect signals from extraterrestrial civilizations. Exoplanet exploration to discover planets within the habitable zone. Analysis of meteorites in search of microbial life. Interstellar travel and theoretical propositions. Although our technology does not yet allow travel outside the solar system, there are theoretical solutions such as wormholes, hypothetical shortcuts in space-time. Alcubierre drive, theoretical technique that allows travel at speeds greater than light through the expansion and contraction of space-time. Space exploration continues to be one of humanity's greatest challenges, opening new horizons for both science and the future of life beyond Earth.